This is SpaceTime, Series 20, Episode 100. NASA looking at missions to a comet or to Saturn's moon Titan. Could the Star of Bethlehem be a real thing? And a supermoon total lunar eclipse to kick off the new year. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has narrowed it down to two final concepts for a robotic mission planned for launch in the mid-2020s. The agency is considering either a comet sample return mission or a drone mission to Saturn's largest moon Titan. The agency announced the final two concepts following an extensive peer review process studying 12 proposals. The Comet Astrobiology Exploration Sample Return, or CESAR mission, would seek to return a sample from the comet 67P Churyumov-Gerasimenko. That's the same comet visited by the European Space Agency's Rosetta mission. The new mission would use the extensive data collection built up by Rosetta to undertake its sample return. The other mission, called Dragonfly, would involve a drone-like rotorcraft that would explore the chemistry and habitability of dozens of sites across the Saturnian moon Titan. Titan's the only place in the solar system other than Earth where it rains. That rain then forms streams and rivers, which flow into lakes and oceans. However, on Titan, the liquid isn't water. That's because water's frozen solid, forming much of the moon's bedrock. Instead, Titan's liquids are methane and ethane hydrocarbons. The CESAR and Dragonfly mission proposals will now each receive funding through to the end of 2018 in order to further develop and mature their concepts. NASA will then select one of these two proposals by the middle of 2019 for continued funding. The selected mission will be the fourth in NASA's New Frontiers portfolio, a series of planetary science investigations. Its predecessors have included the New Horizons mission to Pluto, the Juno mission to Jupiter, and OSIRIS-REx, which will rendezvous and return with a sample from the asteroid Bennu. NASA's also announced the selection of two mission concepts that will receive technology development funding to prepare them for future mission competitions. These include ELSA, the Enceladus Life Signatures and Habitability mission, to try and develop a contamination-free spacecraft, which will then fly to the Saturnian ice moon Enceladus in search of signs of alien life. And Vicky, the Venus In Situ Composition Investigations mission, which would develop instruments capable of surviving the extreme temperatures and pressures found on the surface of Venus. These instruments would use lasers on a lander to measure the mineralogy and elemental composition of rocks on the Venusian surface. You're listening to SpaceTime. I'm Stuart Gary. While we're still in the holiday spirit, let me pose a question. Could the Star of Bethlehem have been a real thing? For astronomy, the idea of three wise men being guided by a star to a stable and little Jewish town called Bethlehem 2,000 years ago does raise a number of problems. But let's for a moment just suppose it really happened. The Magi, Persian sages and astrologers from Mesopotamia, really were drawn to the southern Jerusalem suburb of Bethlehem to view the newborn King of the Jews, the baby Jesus. So, what star were they really following? Well, based on astronomical charts, the best explanation for the Star of Bethlehem would have been a triple conjunction between Jupiter and Saturn, with the two planets coming close together in the sky 3 times over a fairly short period. And this happens during an alignment between the Sun, the Earth, and Jupiter and Saturn. Once the planets all lined up in their orbits, the Earth, travelling faster and on the inside, would overtake the two gas giants, meaning that Jupiter and Saturn would appear from Earth to change their direction in the night sky. Now, the event would be made even more significant because it took place in the constellation of Pisces, one of the signs of the zodiac, and such an event would only happen about once every 900 years. And so for a bunch of ancient Babylonian astrologers, this might have been a big deal, a sign that something very significant was occurring. And what could be more significant 2,000 years ago than the birth of a new king for God's chosen people? Another possibility, one that I personally like best of all, is that the Star of Bethlehem was actually a comet. And lo and behold, there just happened to be a comet in the right place at the right time. Chinese astronomers, known for their meticulous record-keeping, recorded a bright comet appearing in the constellation of Capricorn in the year 5 BCE. And that pretty well matches the date of the Bethlehem star. Remember, although we talk about Jesus being born 2,000 years ago, most religious scholars believe he was actually born about 6 years earlier. So the 5 BCE comet would have been about right. Also, the 5 BCE comet would have been seen in the southern sky as seen from Jerusalem, and Bethlehem is south of Jerusalem. Then you've got the fact that comets look like they're standing above the Earth with their coma and tail looking like an arrow. And the head of the 5 BCE comet would have been close to the horizon, with its tail pointing vertically upwards like a Las Vegas neon sign pointing to a casino. A less likely but more famous cometary candidate would have been Halley's Comet, which would have been visible around 12 BCE, but that might be a bit too late for our Star of Bethlehem. Of course, the trouble with comets is that they're usually regarded as portents of doom, and the birth of a new king would have been an auspicious occasion, except of course that is for the current king of the day, Herod. Now, a third possibility worth considering is the arrival of a new star or nova, an explosion of material built up on the surface of a neutron star, causing it to suddenly, dramatically brighten for a few months before fading away again. And there are records indicating a nova did occur in the northern constellation of Aquila in about 4 BCE. Again, not a bad match. And of course, novae aren't as common as comets, and so are more likely to stand out as something special. To find out more about what the Star of Bethlehem could have been, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
The Star of Wonder, or the Star of Bethlehem, the star that guided the three wise men. Often the question comes up as to whether or not it's real or was real. What was it really? Or didn't it happen at all, and it's all a myth? It's a good question, and one that's probably been analysed over time, and do we know the answer?
We've got a few answers, some of which are more credible than others, Andrew. The biblical account is in the Gospel according to St. Matthew, and basically when you read through that, it talks about some kind of subtleties. For example, they'd seen a star in the east, these magi, the three wise men. They were probably Persian sort of mystic astrologers. That's probably their origin. They journeyed to Jerusalem because they had interpreted the astrological events as being about a new ruler, and they basically asked the king, who's of course Herod, about this this new ruler, and he was clearly miffed about this because he was the boss. But what's really interesting, and this rules out many astronomical possibilities, Herod had to ask the wise men when and where the star appeared, because he and his own astrologers couldn't see it or weren't aware of it. So that sort of rules out things like a supernova or a comet, a bright object, and it means that it has to be something a good bit more subtle than this. And it turns out, and this is it's an explanation that's been around for quite a long time. I remember talking about it in Edinburgh 30 years ago, but it's basically to do with the motion of the planets and unusual configurations of the planets. You also have to interpret the biblical account in a way that perhaps is a little bit more investigative than just taking the King James version that talked about the star in the east guiding the wise men, and that it stood still over the place where Jesus was born. It's not that kind of phenomenon. For a start, the journey from Jerusalem to Bethlehem would take these guys to the south rather than to the east. So they've got to be aware of things taking place in the east, and basically is something that we would probably call it a heliacal rising. That it means that something like, and it's probably the planet Jupiter that we're talking about, a very bright object, just appears above the eastern horizon before dawn breaks. It's that kind of thing. And so that is one of the things. There are all sorts of other astrological subtleties. Jupiter was in the constellation of Leo, which was a regal constellation. It basically had later on had a lunar occultation. So exactly what we've just been talking about, the moon passed in front of Jupiter. And the idea of it standing still comes about probably because of the way planets commonly behave. The outer planets, as you see them from the Earth, they actually progress through the sky in a kind of zigzag pattern, because they go forward for a long time, then suddenly they stop and go backwards, and then they go stop again and then go forwards. And it's because of the way that our vantage point on Earth is moving around the sun. It gives us a different perspective on the outer planets.
And so, just by way of an explanation to that, I think I've witnessed something similar while taking off in an airliner from Sydney Airport. I remember looking out the window as we took off once, and we were banking east to go out over the ocean, and I looked out the window and there was another airliner that had taken off ahead of us, and as I looked at it, I could swear it was not moving.
Yeah, it became stationary.
Yeah,
that's right.
Yeah, and so that's the sort of effect you're talking about.
It is. It's the same sort of thing. That's right. You sort of overtake it. We call the times at which the planets appear to stand still, with great imagination, we call them stationary points. And so, that's when that phenomenon happens. So all these events took place actually in 6 BC by our contemporary dating. And it's throughout most of 6 BC, from about April to December, there were all these really significant astrological portents that informed the wise men that they needed to find out what was going on down there near Jerusalem. And so there's really rather a lot in that account that you can trace back to early mythology and early astrology. One of the many scientists who's written about this stuff is a professor of astronomy at Vanderbilt University. His name is David Weintraub, very prolific astronomy writer. He winds up his account of the Star of Bethlehem by saying, Matthew wrote to convince his readers that Jesus was the prophesied Messiah. Given the astrological clues embedded in his gospel, he must have believed the story of the Star of Bethlehem would be convincing evidence for many in his audience. It's just saying that these astrological ideas were probably pretty well instilled in people's minds, even if they weren't practicing mystics or astrologers like the three wise men were.
Interesting. So I suppose we can say that this was a normal event, and there's been a bit of Chinese whispering over the last couple of thousand years. One final question. Can we... I know you can do a lot of sort of reverse plotting in astronomy using mathematics. Can we backtrack mathematically to see if something like this happened around that time, or is that too complicated?
Yeah, exactly. Yes, that's exactly what's happened, because you can do that, many, many thousands of years before the birth of Christ. So that's why astronomers are so, I guess, enamored of the idea of it being one of these conjunctions plus stationary points plus the rest of it. And just to, clarify slightly, I think the combination of events that took place in 6 BC was pretty rare. There was the heliacal rising of Jupiter, there was various appropriate constellations, other planetary positions, this occultation. It's really strong stuff when you plug it into the astrological understanding of the time. These were relatively rare planetary configurations.
So for people to witness it at a time where knowledge of the universe was fairly limited, they would have seen that as some kind of miracle or some sort of sign, and that's right. What's been documented.
Indeed, that's right. And the sky watchers, the sort of professional sky watchers, which were the wise men, they got it, whereas Herod and his gang didn't, because they hadn't seen these phenomena.
Yeah, fascinating. All right, well, there's an explanation. Accept it or not.
Yes.
But that's...
as with all these things, you have to preface any kind of astronomical discussion of the Star of Bethlehem with basically got to take out the possibility of it being a miracle. Because if it's a miracle, all bets are off. Astronomy doesn't deal in miracles, and we don't know about that stuff.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Scientists say they've detected no alien signals. For that matter, no evidence of extraterrestrial technology of any sort coming from that strange cigar-shaped interstellar visitor which sped through our solar system during September and October. The 400-metre-long, 40-metre-wide asteroid, designated A2017U1 and named Oumuamua, the Hawaiian name meaning messenger or scout, has been at the centre of astronomical attention ever since its unexpected detection. After its discovery, the Breakthrough Listen collaboration, dedicated to finding signs of extraterrestrial intelligence, announced plans to study the strange visitor for artificial signals. The collaboration, funded by Russian physicist Yuri Milner, pointed the 100-metre Greenbank radio telescope in West Virginia towards the asteroid, but no signal was detected. The first of 4 planned observation blocks was undertaken over 6 hours on December 13, monitoring L, S, X and C radio bands spanning billions of individual channels across the 1 to 12 GHz range. The instrument accumulated some 90 terabytes of raw data during the observation, searching for signals that may be of artificial origin. But despite the impressive computational power of the Breakthrough Listen computing cluster at Greenbank, the large data volumes mean it will take some time to sift through. The asteroid was discovered back on October the 19th by the University of Hawaii's Pan-STARRS 1 telescope during NASA's search for NEOs or near-Earth objects which pose a potential threat to Earth. The NASA team were able to plot the object's current trajectory, determining that it came from the direction of the constellation Lyra, cruising through interstellar space at 25.5 kilometers per second. The interstellar visitor approached our solar system from almost directly above the ecliptic, the orbital plane on which the planets and most asteroids circle the Sun. This means our visitor didn't have any close encounters with the 8 major planets during its plunge towards the Sun. It crossed under the ecliptic on September the 2nd, just inside Mercury's orbit, then made its closest approach to the Sun on September 9. Pulled round by the Sun's gravity, the object made a hairpin turn under our solar system, passing under the Earth on October the 14th at a distance of about 24 million kilometres. That's some 60 times further away than the Moon. It was shortly after that when Pan-STARRS first spotted it. Oumuamua is now shot back out above the plane of the planets and is travelling at 44 kilometres per second with respect to the Sun, speeding towards the constellation Pegasus. It's now already well over 300 million kilometres from the Earth. It passed the orbit of Mars in November and will pass Jupiter's orbit in May next year before exiting the solar system beyond Saturn's orbit in January 2019. Its trajectory and speed mean it's definitely on its way out of the solar system and won't be coming back. You're listening to Space Time. I'm Stuart Gary. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in both the Julian and Gregorian calendars. The name originates in the Latin word for door because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to an ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. January is also important because after being claimed in the name of England back in 1770 and then invaded and colonised by the British in 1788, it was on January the 1st, 1901 that Australia ceased being a group of British colonies under the control of Mother England and became a single united self-governing nation. So, happy 117th birthday, Australia! Although the actual birthday is celebrated on the day of colonisation or invasion, depending on your viewpoint, January the 26th. For astronomers, January marks Earth's closest orbital position to the Sun, perihelion, about 2 weeks after the December solstice. Now, the reason we have perihelion is because planets don't orbit the Sun in perfect circles, but on ever-changing elliptical orbits. The shape of this orbit varies due to gravitational influences from other planetary objects, and in Earth's case, that especially includes the Moon, which is almost massive enough to be a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. The difference is known as eccentricity. The 2018 perihelion will occur on Wednesday, January the 3rd at 16:34 in the afternoon Australian Eastern Daylight Time. That's 12:34 a.m. US Eastern Standard Time and 5:34 in the morning Greenwich Mean Time. At that precise moment, the centre of the Earth will be 147,097,233 kilometres from the centre of the Sun. Of course, around 6 months later, and about 2 weeks after the June solstice, at 2:46 in the morning on July the 7th, Australian Eastern Standard Time, Earth will be at its farthest orbital position from the Sun, aphelion, when the centre of the Earth will be approximately 152,095,566 kilometres from the centre of the Sun. That's 12:26 p.m. US Eastern Daylight Time and 4:46 in the afternoon Greenwich Mean Time on July the 6th. However, it's important to remember that temperatures on Earth aren't determined by Earth's orbital distance from the Sun, but rather the angle of the Sun's rays striking the Earth. In summer, the Sun's high in the sky, so the rays are more concentrated, hitting the Earth at a steeper angle. Consequently, days are hotter. In winter, the Sun's lower down in the sky, and the rays are more diffuse, striking the Earth at a shallow angle, so the days are colder. Okay, let's start our celestial tour with the brightest star in the night sky, Sirius, the dog star. So called because it's the brightest star in the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the night sky. As well as being one of the nearest stars to the Sun at just 8.6 light years, it's also intrinsically bright, 25 times brighter than the Sun. Now, you've just heard me use the term light year. That's a term we use a lot in astronomy. A light year is about 10 trillion kilometres, the distance a photon of light can travel in an Earth year at 300,000 kilometres per second, the speed of light in a vacuum and the ultimate speed limit of the universe. If we move to the north of Sirius, and staying to the east of the constellation Orion, which dominates the sky this time of the year, you'll see the bright star Procyon in the constellation Canis Minor, the little dog. Procyon is a binary star system comprising a spectral type F main sequence white star, Procyon A, and a faint white dwarf companion, Procyon B. Located some 11.46 light years away, Procyon A has about 1.5 times the mass and twice the radius of the Sun. Procyon A has about 7 times the luminosity of the Sun. That makes it unusually bright for a star of this type, and that suggests it's starting to evolve off the main sequence. The main sequence is where stars fuse hydrogen into helium in their core. By moving off the main sequence, Procyon A is about to expand into a subgiant as burning moves further out from the core. As it continues to expand, the star will eventually swell to about 80 to 150 times its current diameter, in the process becoming a red or orange giant. This will probably happen within the next 10 to 100 million years, the blink of an eye in astronomical terms. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of 15 astronomical units. An astronomical unit's another term you're going to hear a lot. It's the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Looking due north just above the horizon this time of year, you'll find the bright yellowish star Capella. Located some 42.9 light years away, Capella is the brightest star in the constellation Auriga, the charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times and in modern-day sci-fi movies. Although it appears to be a single star, Capella is actually a system of 4 stars in 2 binary pairs. The primary pair comprises 2 bright yellow giant stars, each of which are around 2.5 times the mass of our Sun. Having exhausted the hydrogen in their core, both stars have cooled and expanded out to become giants, in the process moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of our Sun. Known as an aging red clump star, Capella AA is now fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller and hotter subgiant, about 73 times as luminous and with almost 9 times the radius of the Sun. It's now in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the night sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the primary pair. They consist of two faint, small, relatively cool spectral type M main sequence red dwarf stars. They've been designated as Capella H and Capella L. Almost directly overhead this time of year, a celestial position known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Canopus is located some 310 light-years away in the constellation of Carina the Keel. Canopus is another core helium-burning giant, no longer on the main sequence. It has about 8 times the mass, 71 times the radius, and 10,000 times the luminosity of our Sun. Canopus is another bright source of X-rays, again probably produced by its corona being magnetically heated to several million Kelvin. The temperature has likely been stimulated by fast rotation combined with strong convection percolating through the star's outer layers. No star closer to Earth than Canopus is more luminous than it. In fact, it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which time they're passing the solar system at a much closer distance than what Canopus is. In fact, it was about 90,000 years ago that Sirius moved close enough to become brighter than Canopus in our night sky, a situation which will remain for another 210,000 years. And in about 480,000 years' time, Canopus will once again become the brightest star in our night skies, and will then remain so for at least 510,000 years. The name is generally considered to have originated from the mythical Canopus, who was a navigator for Menelaus, the king of Sparta. Canopus forms part of the stellar association or astrium known as the False Cross, which straddles the constellations Carina the Keel and Vela the Sails, and is often confused with the real Southern Cross, which this time of the year is far to the south. January plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate from recognizable constellations, like Leo's Leonids, Gemini's Geminids, and Orion's Orionids. But the Quadrantids are meteors that appear to radiate from the location of the former Quadrans Muralis constellation. In the early 1920s, the International Astronomical Union divided up the sky into 88 official constellations. More than 30 other historical constellations failed to make the cut. The Quadrans Muralis was one area of the sky which missed out. It now lies within the boundaries of what is the official constellation Bootes. The radiant point of this shower, near the Big Dipper, is between the end of the handle and the quadrilateral of stars making up the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers, with up to 80 meteors an hour. They're best seen from the northern hemisphere. Also, unlike other meteor showers, which tend to peak for a day or two, the Quadrantids only peak for a couple of hours. And while most meteor showers are produced by the Earth passing through the debris trails left behind by comets, the Quadrantids are one of just 2 meteor showers produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke up centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to have been the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was rediscovered by the Near-Earth Asteroid Telescopic Survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December. They're caused by debris from the asteroid 3,200 feet on, which is also thought to be the remains of a comet. January this year will also play host to a total lunar eclipse. A total lunar eclipse occurs when the Sun, Earth and Moon are aligned. During this event, the Moon passes completely through the Earth's dark shadow or umbra. Even though the Earth completely blocks out sunlight from directly reaching the surface of the Moon is still visible during a total lunar eclipse. You'll see the Moon will gradually get darker. It then takes on a rusty, even blood red colour, as light from the Sun refracts through Earth's atmosphere and undergoes Rayleigh scattering, leaving only the longer red wavelengths as all of Earth's sunsets and sunrises happen at once to indirectly reflect onto the lunar surface. A total lunar eclipse can also look yellow, orange or even brown in colour, depending on how different types of dust particles, smoke and clouds in Earth's atmosphere allow different wavelengths of light to reach the lunar surface. The event starts at 10:48 p.m. Australian Eastern Daylight Time, late on the night of January the 31st, and will end at about 2:12 Australian Eastern Daylight Time during the early morning hours of February the 1st. As well as Australia, the lunar eclipse will be visible across most of Western North America, Eastern Asia, New Zealand and right across the Pacific. Jonathan Nally, editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the January night skies.
G'day, Stuart. Well, we'll begin as always with the evening sky, and we'll begin with the constellation that everyone wants to see, which as usual is the Southern Cross. Now at the moment it's still upside down, very low down on the southern horizon for most people in the southern hemisphere, you know, if you're at the southern temperate latitudes or further south. So Sydney or further south than that, it's upside down in the south. As the night goes on though, it'll rise higher and higher in the south-southeast as the Earth rotates, and it'll end up lying on its sort of left-hand side, probably about halfway up the sky. Pretty easy to find. The Southern Cross is not a cross in the sense of a plus symbol, which you might have on your keyboard. It's a cross like a crucifix. And in fact, the correct title for the Southern Cross is crux or crux, which means a crucifix, but everyone just calls it, of course, the Southern Cross. Now, the Milky Way, that's our galaxy, of course, seen from the inside. It's stretching right across the sky from the south to the north, and its star fields contain some fantastic constellations and deep sky objects, as astronomers call them. Starting at the south, there's the Southern Cross, then there's Carina, then there's Vela and Puppis. Those three constellations together used to be a larger constellation called Argo Navis, which is the ship of the Argonauts, and then it got split up. So you got Carina, which is the keel, Vela, which is the sails, and Puppis, which is the poop deck. You look in the sky, you wouldn't see them, of course. They just join the dot star things. They don't look anything like poop decks or keels or sails. But anyway,
what does a poop deck look like?
You know the old galleons and things. I think the poop deck is the bit at the back where the
little raised bit at the back.
Yeah, I think that's the poop deck. Yeah, where everything, where the captain would stand. I think they had.
I thought they were aft castles and forecastles and things like that. Poop deck sounds right. Yeah.
I think that's the poop deck. Yeah. If we're not, someone will tell us.
I'm sure we're going to get a few emails or at least Twitter responses with other suggestions of what poop deck could be.
Exactly right, yes. Well, yes, they named things funny back in the old days in the sky. So you've got those three constellations in the Milky Way. Then further north you've got the constellation Canis Major, which is the larger dog, and of course it's got the bright star Sirius. And going a bit further north you end up with Orion, Gemini and Taurus. All of those constellations, all of the ones I've mentioned, have amazing star fields, star clusters and nebulae. A lot of them can be seen just with a pair of binoculars, but if you have a telescope or you know someone's got a telescope, it'll bring out a lot more detail. Now, more or less directly north in the mid to late evening during January is a tiny clump of stars called the Pleiades, or the Seven Sisters. We spoke about this cluster last time. It's a group of actually around 1,000 stars, a big star cluster, quite a long way from Earth, but a lot of those members of that cluster, a lot of those 1,000 stars are quite dim, so you can't see them with the naked eye. To the naked eye under dark skies, most people can see 6 or 7 of these stars. Sometimes you have to not look directly at this little cluster, you look out sort of the side of your eye. That's called averted vision, and that helps because the light comes into your eye and doesn't hit the middle of your retina, which is where you have the colour receptors. The colour receptors are not good at picking up dim light, nighttime stuff. So you want to try and look out the side of your eye a little bit so the light hits the rest of your retina, which has the black and white receptors, which are more sensitive to faint light. That's why, in the middle of the night, if you go out in the dark night, everything looks black and white. You don't see a lot of colour because that retina, the middle of the retina where the colour sensors are, doesn't really fire off too well.
Yeah, the colour only starts when you accidentally knock your foot against something.
When you're stumbling around in the dark, yeah, exactly. So that's the Seven Sisters. Now, some people actually claim to see about 11 stars if they've got really good eyesight. I can believe that. And binoculars work really well on this little cluster. So if you have a pair, take a look at the Pleiades and you certainly won't be disappointed. In the other side of the sky, back down in the south again, high up in the southern sky, 2 galaxies that you can see with the unaided eye, as long as you don't have too much light pollution around, like lots of street light. These galaxies are the small and the large Magellanic Clouds. Very well known, they've been famous for years. They're named after the explorer Magellan, the Magellanic Clouds. Astronomers find them really quite handy because they're not too close and they're not too far away. They can make out individual stars in them quite easily. The most famous example of that is the supernova 1987A, which was a huge stellar explosion in the Large Magellanic Cloud that we spotted on Earth back in 1987, although it had actually happened almost 170,000 years before. It's just that it took that long for the light to get to us from that galaxy and for the explosion to reach our eyes and our photographs and telescopes and things.
And we still don't know what's become of it. We know the supernova happened, it's still expanding, but we don't know what's become become of the progenitor star? Is it a neutron star? Is it a black hole?
What happened to it? Yeah, when you get these big supernova explosions, generally they will form into a neutron star, or if it gets squashed even further, black hole. If there's a neutron star, then chances are we should have been able to detect its presence by now. There are certainly circumstances under which we wouldn't have been able to detect its presence. So that we haven't been able to detect the presence of a neutron star means either it went further and went to a black hole, or it is a neutron star and it's just pointing in the wrong direction or something. So yeah, it's an interesting thing.
It's a mystery.
They'll get to the bottom of it one day. They really will, I'm sure.
Yeah, the problem about the idea of it being a black hole, and I'd be excited about that, of course, the problem with it being a black hole is that what we've found in the last few years is that when a star explodes to become a black hole in a supernova event, the supernova event may not be seen at all, because as soon as it begins, the whole thing collapses into the singularity. So you don't actually see a supernova event.
Yep, that's exactly right. Yep, so it's a real mystery with the 1987A. It's the best studied supernova of all time, in a sense. Well, put it this way, the supernova remnant is the best studied, and there's certainly we were able to follow the light of the explosion as it brightened and then dimmed away for quite a long time. Actually, I don't know. Would you call it the best studied or not? It probably is.
It's the first one we're able to study the neutrino emissions from as well.
That's right. Yeah, in most senses it probably is. In fact, I mean, I know that with the super gear we've got these days, you can pick up supernovae and follow them for a very long time. And of course, they've got lots more supernovae spotted these days, so you build up bigger statistics. Back in 1987, you're only getting a dozen supernovae a year or something like that. But this one was so close, therefore was so bright and could be seen with the big telescopes, made it very easy to study. So yeah, we'll have to find out what happens to that. Now, turning to the planets, none of the ones bright enough to be seen with just the unaided eye are visible in the evening sky during January, so the evening sky is a bit devoid of old planets. The ones that are visible can be seen above the eastern horizon before dawn, so you've got to be a bit of an early riser. Mars and Jupiter are the two most prominent ones, and they'll actually appear very close together for most of the month. And in fact, on January the 7th, they'll seem to be almost on top of one another. So if you're up early, take a look. It should be really great to see. You won't be able to miss them. Jupiter's big and bright, and you'll see another dimmer reddish sort of star, in inverted commas, very close to it. That's actually the planet Mars. They'll look great together. Mercury and Saturn are together as well, low down on the eastern horizon before dawn. On the 13th and 14th of January, they'll appear right next to each other. And again, they'll make a very nice sight. If you're wondering where Venus is, well, it's around the other side of the sun at the moment, so it can't be seen. But it's going to pop back into our skies in February, when we'll be able to see it above the western horizon in the evening after the sunset twilight sort of begins. Now, Stuart, there's going to be an eclipse of the moon in January. It's going to start on the night of January 31st and finish in the early morning hours of February 1st for stargazers in Australia. A lunar eclipse, of course, is when the moon moves into the Earth's shadow. This one will be pretty good, too, because the moon's going to go into the deepest and darkest part of the Earth's shadow, called the umbra. Depending on your time zone, it'll determine what time of night this begins. So you can look that up. It's in the magazine Australian Sky and Telescope, and there'll also be lots of information on the web. Now, there's a good chance the moon will go a bit red when it's at maximum eclipse, too. You very often get this for total lunar eclipses. This is because even though the Earth will be blocking direct sunlight from striking the moon, some light will still be refracted or bent through our atmosphere and shine onto the lunar surface, and it's the red light that tends to make it through.
All the sunrises and sunsets of the Earth at once.
Basically, yeah, all the light sort of creeping through the outside edges of the Earth's atmosphere and bent onto the moon. So if you get a chance to see that, so January 31st, the night of January 31st, late evening it's going to start, go through to the early morning hours of 1st of February. Yes, if you've got some clear skies, make sure you get out and enjoy that. It should be really quite great to see. And that, Stuart, is what's happening in January's night sky.
That's Jonathan Nowley, the editor of Australian Sky and Telescope magazine. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.